Since we're talking about weather this week, it makes a little bit of sense to talk about climate change. For example, here I have our Portland high temperature time plot that we looked at in a previous video. Here I limited to January 2007 through December 2018, so just full years only. So weather is what's happening on a specific day at a specific location, and climate is what sort of happens over longer time scales with some regularity. You know, like it gets hotter in the summer, colder in the winter, and we see those general patterns repeat very nicely, whether we're looking at our daily plot or our monthly average. So what we can do with these plots is we can add a trend line. So go here to the plus sign, and then go to trend line. Now you can just check it on, but let's do one more thing too. Let's go over here to this arrow, and we will click more options. And that brings up our sidebar where we do a linear trend line. And down here in the next module, we talk a lot more about what these equations and stuff mean. But for now, let's just click on display R² value on chart and turn that off. And you can see it added a trend line. It's kind of hard to see with those tiny dots. And then it put this thing called R² over here. So I'll drag that up here, and I will make the font size 20. OK, so again, we talk more about what this means later, but notice the trend line is going up over time. It's very slightly going up. This R² value, the thing to notice right now is that it's 0.0073. That's extremely close to 0. And it's extremely close to 0 because this goes up a lot and down a lot. So it's really tough to tell if there's an actual upward trend, or maybe what we're seeing is just the result of, random noise. If this year was a little warmer, that would pull the whole line up. If this winter was a little colder, maybe that's pulling the line down. And we can look at the same thing, though, with our monthly averages. If we add a trend line, and let's add the R² value to that one, too. But you see the same thing for our monthly averages. The R² value is very close to 0, but it is still an upward trend. So, of course, that's just for Portland. Portland International Airport is just one location in the entire world. But it turns out that there are websites like this one, the Climate Reanalyzer, that gives you the United States annual average temperature anomaly. Temperature anomaly is the amount we are above or below some sort of baseline. They take like 1950 to 1980 and they say this is normal. And then they look at how far above or below that other years are. And you can see for the United States, we have the same sort of trend as we're often below that normal in here. And then in recent years, we've been a lot above that normal. But the great thing about this tool is it's not limited to just the United States. We can just click on Oregon directly. The map doesn't change, but this gives us Oregon. Up until about 1925, we were always lower than that average. And in recent years, we have only had one year right here where we dip just slightly below. Otherwise, it's much higher. So you can play around with this thing a lot. You can look at average, max, min, precipitation, all that stuff. But no matter how you look at this, our max temperatures are climbing up in Oregon. Our minimum temperatures are climbing up in Oregon. Our average temperatures in Oregon are climbing up. And you can pretty much look at any state and look at data to do that as well. So it's getting hotter on Earth and in the United States, as we see in this tool. How bad is that? Well, here we have this XKCD comic where it sort of shows since 20,000 years ago was the middle of a previous ice age. So it was negative 4.3 degrees Celsius 22,000 years ago. And you notice with a negative 4.3 degrees Celsius, you can read most of this on your own. But here's Boston's skyline. Here's the thickness of the ice sheet. Same thing with New York. Here's the Statue of Liberty. The ice sheet was about as thick. And so if you scroll down this, you can read a lot of interesting stuff about sunlight and earth warming or whatever. But, and there's some technical notes. The guy who runs this is kind of a scientist, nerd, data coder. He's just really an interesting fellow, apparently. But it kind of goes through the Earth's warming and, looks at all these little things that happen. And here you see it's actually above the baseline. And then it starts getting back towards the baseline here. And then we start, 500 BCE, so 2,500 years ago, it's about average. And then, of course, here's a little ice age here. And then in recent times, it really just whoop straight up. So before, these changes were very gradual and they occurred over periods of thousands of years, and here they are just over less than 100 years. So then we go to this site run by NASA, climate.nasa.gov, and it can give us similar information. Here's the global land-ocean temperature index, which is sort of an average of every spot on the Earth. We are right now 0.8 C above our average from 1951 to 1980, I believe. And so then the other question, is that, okay, well, everyone says it's carbon dioxide. Why do we know? Well, they have information on that. Carbon dioxide just scientifically is a greenhouse gas. They can prove that. And of course, that's been going up as well. This is just since 2005. This is direct measurements. If you scroll down a little bit, you can see indirect measurements where they use ice cores. As ice freezes, it traps gas. And then they can dig up those cores from where the ice sheet is sometimes miles thick, and they can look and see how much CO2 is trapped in there. But the great thing about this site is you can also download the data, which of course I did. So we go over here, and the data here is downloaded kind of weird, but basically I cleaned it up a little bit. So made it so we could do a time series. And they do CO2, but sometimes there's weird things like when data is missing, they put negative 99.99. So in the next column, they kind of give their best guess. They interpolate, is what you call when you try to figure out a value between two other values. It's called interpolation. So this is their best guess for what it was, even though the data is missing. So what I can do is I can select all of this monthly from early 1958 all the way up through 2018, and I can make my own time series. And that looks super weird, so we should probably change the axes here. And again, I played around with this ahead of time to know that a date of 21,000 works pretty well. And then we should change this axis to, so we'll do a minimum of 300. And this does not look like much, but when we blow it up, we can see something pretty interesting. Is look at this. We can now see what we have are annual cycles. So carbon dioxide actually goes up and down every year in the environment. In the summer, since there's more plant life in the northern hemisphere, so northern hemisphere summer, the carbon dioxide goes down a little bit as plants grow, and then it goes back up in the winter as either plants die or humans just add to it. So we've got this interesting long-term trend made up of smaller trends. And if you go back to NASA's website, you can see they're just showing the long-term trend. They've sort of taken that annual fluctuation out of it, which is something you can do if you took a trigonometry class. You might recognize that this is a repeating waveform. So mathematically, you can just kind of take that out and look at the trend. So in the next video, you're going to be using your custom data to see if there's any evidence that your location is warming, and then we're going to report that back for the rest of the class.